This presentation discusses data in motion. The premise of the IT security technology is built upon the notion that if commands can be hacked, lost, intercepted, or stolen, then stop using real commands. Use microtokens instead. This is why we created the technology to secure data via MicroToken Exchange. Today, cyber professionals attempt to secure data tunnels as well as utilize encryption methods such as PKI and AES methodologies in their effort to stop many forms of malicious attacks. These methods to date have proven ineffective in most real-life use cases. The use of real commands allows for reverse engineering as well as spoofing of these commands while allowing vulnerabilities such as replication and execution of commands by bad actors. It's obvious that today's methods to secure data simply do not work. Every day we hear about IoT device breaches, including some of the world's top car manufacturers, the largest banks, as well as the US government. Tens of millions of dollars have been spent to come up with a secure architecture that works, yet thus far others have been unsuccessful in their attempts to do so. Data analysts as such in several Forrester research reports on the hacking of automobile control systems talk about cars being run off the road as well as key fob signal interception resulting in numerous car thefts around the world. It's already been demonstrated that Jeeps can be hacked and run off the road. In news currently is that the newest Tesla Model X, which was touted to be unhackable, well yes, it's been hacked. World leaders are on edge 24/7 with regard to securing industrial control systems for the critical infrastructure. Today, more and more devices are becoming connected. The scope of the problem is growing and the importance to solve the IoT security challenge is paramount. IT Security MicroToken Exchange, or MTE, is the solution to securing commands to connected and intelligent devices, including those in and around IoT. To begin, here's a little history. The inventors of MTE were instrumental in the creation and development of the Check 21 system while working on the back end of the Federal Reserve. At that time, they were using tokenization in a variety of ways, but it was limited to 16 characters. Letters and/or digits. Back in early 2015, during a presentation to the U.S. Army Tank, Automotive, and Armaments Command, or TACOM, our team was asked if we could apply our microencryption MTE methodologies to data in motion. We went back to our labs and did just that. This was where the IT Security Commander MTE capabilities came from. Today, through the efforts of our team, and developers and engineers, our solutions have expanded to an array of award-winning data security solutions. By the way, the two original inventors are still on our staff today. IT Security MTE is unique in its capability as agnostic to the type of bit stream that is used to transmit command data. Yet it is absolutely a perfect solution to secure commands over the internet. It's also designed to work seamlessly over Bluetooth, satellite, telephone, near-field communications, and most other forms of transmissions. This was a key concern as MTE was being developed. Additionally, MTE for data in motion does not require encryption. With the deployment of MTE commands to both connected and intelligent devices will remain unscathed, secure, and unassailable. Through the remainder of this presentation, we'll go through why. When MTE is utilized and deployed, no real data or no real command is ever sent to be executed. Every command is replaced with microtokens. Microtokens only execute pre-programmed commands, which are stored in paired libraries, and access is never granted to entire systems, only to those devices in which they're paired to. Microtokens can only be interpreted by paired devices and are meaningless if intercepted. Devices can be paired one-to-one or one-to-many. Actual valid microtokens are hidden within our digital chaff. Tens of thousands of false characters can be generated in milliseconds. Each real microtoken is obfuscated within a microtoken cluster. This will become more clear in a few moments with a visual depiction. What you're viewing on the right side of the screen is a sample microtoken cluster packet. As you see, there are hundreds of digital characters contained within the cluster. Somewhere within this cluster, the real microtoken exists. If a hacker were to intercept a specific command, this is what they would potentially uncover. Most would think it's some form of encryption and attempt to hack it over and over. Since there's no encryption, there's no way those attempts would ever be successful. In this illustration, the real microtoken has been identified for you to see. The cluster has been artificially broken apart so you can visualize all the individualized microtokens as chaff tokens. The microtoken highlighted in green in this case is the real microtoken that will execute the command change the light from blue to green. Within our identification, the microtoken would be indiscernible from the surrounding data and chaff contained within the packet. To add to the security of the microtoken, command becomes instantly obsolete in fractions of a second in most cases. The real microtoken is continually randomized with regard to its place within the digital chaff. It is never the same command and always changing locations. Even the amount of digital chaff is randomized with every command that is sent, as well as the payload size. These added security features support our claim that we believe the IT security commander MTE technology is unassailable. MTE technology is both better and stronger than encryption. Our advanced indirectional technologies make sensitive data invisible to hackers and cyber terrorists by creating an invisible shield. Since our packet sizes are relatively small and lightweight, we eliminate the need for heavy processing power to execute commands. With the utilization of MicroToken Exchange, MTE, the ability to replicate discernible values is eliminated. Even in the event of a man-in-the-middle attack that captures every transmission, a hacker can never discern a real value or any of the previous commands that were ever utilized to execute a command ever again. There is a need not only for the highest levels of security, there is an absolute requirement for near real-time speed. Encryption-decryption schemes are simply not fast enough in some critical cases. Encryption security protocols require heavy processing power. The stronger the encryption, the more processing power is required to encrypt and decrypt. With encryption, both the sending device and receiving device must manage keys, thus requiring even more processing power and time. In many cases, the same information along the same frequencies utilizing the same data and encryption is repeated over and over again, making it extremely susceptible to rogue attacks by bad actors. The fact is that some common encryption algorithms have been broken. Some believes this includes AES 256. With the advent of the supercomputer being that encryption is based upon mathematical computations, it's believed that most all encryption of today will be broken to some level in the near future. It is IT security's belief that since MTE does not utilize encryption, no supercomputer nor bad actors will be able to reverse engineer the MTE security protocols and capabilities. IT security, MTE for data in motion, does not require a digital vault since it is generally a security as a service model. It also is available as a platform as a service model as well. MTE, however, can provide both access and use of the digital vault in a variety of ways to be utilized to accomplish specific related tasks, such as moving large amounts of data securely. Okay, so why utilize the MTE digital vault? Our MTE for securing commands can be combined with our ability to secure data at rest to provide an unassailable methodology to update software and/or firmware within system architectures. We initially pair each individual piece of data with a microtoken. We apply our MTE methodologies to locate that data and make it accessible in real time when required. Each piece of data is individually tokenized and encrypted with the client's specific encryption. We are agnostic to the type of data a client wishes to secure, and if they already have some form of encryption that they're using, they can keep using it. MTE will be applied in addition. However, we receive the data. When we ask for it back, we'll return it the same way it was received. We'll then pair 2 or more devices as specified and then send the requested update to those devices, utilizing super encipherment. At the appropriate time, by deploying MTE command security protocols, send a one-time use, time-based permission set of keys with a variety of security roles and protocols allowing for the decryption and the installation of the update. We additionally provide both API integration for clients, allowing for clients to control their own MTE creation and deployment off-premise, as well as a private installation of both our digital vault combined with the capability to create and deploy MTE device library pairings to connected devices themselves. We can also provide a hybrid solution allowing for high levels of flexibility depending on client requirements. Should there be a requirement for private instance of our platform, simply pick and choose the specific data center that you would like us to deploy our MTE technology in. Our client team will then utilize our APIs to connect to our systems to create a high-speed, high-availability architecture on-premise. A full-on licensing model is available when the project size is applicable. Our hybrid flexibility puts full control at our client's fingertips. We're confident that IT security MTE security architecture is unassailable. Our ability to secure commands to both connected and/or intelligent devices obscures device commands, preventing malicious attacks or tampering from affecting unauthorized actions that expose systems to unacceptable vulnerabilities. Our solution is seamless, flexible, and highly scalable as we enhance security without adding new protocols or changing existing data communications from one device to the other. MTE is compatible without disruption to existing architectures and systems. Our security architecture is designed to work and complement existing infrastructures, OEMs, with both existing and pre-built components systems. To deploy MTE to secure commands requires in most cases the insertion of only 2 lines of code, loading of the MTE software, and it's up and running. We've seen applications where MTE was up and running in hours, not days. MTE has won numerous awards, including Plug and Play FinTech, PC Mag Editor's Choice 4 years in a row, including the coveted Technical Excellence Award for Best Security in the World. Others have won this award over the past several years are Palm for the Palm Pilot, Intel for the Intel chip, Qualcomm, Apple, and others. As you can see on screen, there are high-ranking cybersecurity experts who have given strong accolades for IT security's technology. IT security, MicroToken Exchange technology, and capabilities ensure that sensitive data remains unavailable to exploitation in the event of an internal or external network defense breach. If you have data in your network that you're trying to protect, call IT security today.